All right, so I'm going to talk about another thing to be thinking about in terms of creating your data visualization, and that is coordinate systems. So normally, if you are making a graph or a chart, you might be thinking about a Cartesian coordinate system with an x-axis and a y-axis, or if you're making a 3D chart, x, y, and z axes, right? These are flat, you know, uh, two sort of two directional, I guess is what you'd want to say. Um, but you can also have charts and graphs that use a polar coordinate system. So, like a pie chart, right, uses coordinates that are placed along a radius and have an angle. Um, and they can also have a distance, from like the radius can be different depending on the magnitude of some characteristic potentially. Um, and then you have geographic coordinate systems, right? And those are not just flat on the paper because we're representing things that exist in the real world, and the real world is a crazy semi-sphere or a spheroid, right? So your geographic coordinate system is based on your datum, and your datum is made up of a bunch of different elements to try to mimic the actual shape of the three-dimensional Earth, which is not a perfect sphere. Okay, so your datum is the model of that 3D Earth. Okay, and then a geographic coordinate system is usually based on latitude and longitude, and you would think latitude and longitude are the same no matter what geographic coordinate system you have, but that's not true. Actually, the exact coordinates of your latitude and longitude depend on what datum you're using, okay, which is differently accurate. So they've gotten more accurate over time. Newer datums are more accurate, but also some datums are more accurate for certain areas of the Earth, right? Because no model is perfect in recreating the shape of the Earth. And so some are better for some parts of the Earth than others, right? A geographic coordinate system, its units are most often latitude and longitude coordinates, okay? So the units that it'll be using to measure those are degrees, right? Angle degrees. Most of the time when you're making a map in ArcGIS, you want to be using a projected coordinate system, okay? And your projected coordinate system has some ways of taking that spherical Earth and turning it into a flat piece of paper or a flat screen. Okay, so a projected coordinate system takes that globe and makes it into a flat map using math. Um, it starts with your geographic coordinate system and datum, and then it has a few elements to it. It has an origin, 0, 0. We recently saw that 0, 0 on a geographic coordinate system is where? West Africa, off the coast of West Africa is 0, 0. So it has an origin. That's different depending on what projected coordinate system you're using. It has some units of measurement, okay, that it uses as the default. So if you're not sure what units of measurement your map is using, that is probably based on your coordinate system, and you should look at what coordinate system your map is using. Okay, and then it has an area of coverage, global, regional, or local. So you should be thinking in terms of picking up a projected coordinate system to use for your map. You should be thinking about, is my map a map of the whole globe? Is it regional or is it local? And you want to pick one that is as specific to the type of map that you're using and the area as possible. So if you're making a local map of Wisconsin, you do not want to pick a projected coordinate system that is global in scale, right? You want to pick one for Wisconsin. So you want to pick a local one, but a local one that fits within the area of Wisconsin, right? That is going to be the most accurate. If you pick a local coordinate system for like Massachusetts and you're actually showing Wisconsin, it's going to be super inaccurate and distorted because of that. Okay. So all projections have different distortions about them. And if you look at this little drawing here, you can see things that you need to consider in picking a coordinate system for a map. So you need to think about the purpose of the map, and that is going to help you determine which type of distortion you want to minimize. So there's distortions in area, angle, direction, and distance. Different types of projected coordinate systems have different types of distortion. So depending on what you are trying to show, if you're trying to show areas, then you want to minimize the distortion of areas. If you're trying to show distances, then you want to minimize the distortion of distances over across your map, right? So you also need to think about the scale. That's what I'm saying, global, regional, local. And then you want to think about the directionality of your map. So meaning like what part of the globe is it showing, what area. So cylindrical, a lot of projections are cylindrical, some projections are conic, and then azimuthal, meaning sort of like a polar projection, right? I'll go over these. And then the location you want to think about. So you need a projection that, or projected coordinate system that includes the location that you are mapping. And then, the familiarity of your audience with the projection. So one reason you might choose a Mercator projection sometimes is just because people are so used to seeing the Mercator projection that that it's familiar to them and it doesn't look weird, right? If we chose a projected coordinate system that looked really strange to people, that might interfere with their ability to read the map, right? Okay, so here are some examples. There's three types of projected coordinate systems I'm going to talk about based on the type of distortion. Okay, so conformal projections, like the Webb Mercator one that's most commonly used, are ones that don't distort angles. So they're really good for navigation. Webb Mercator projection was based on people having to navigate by sea, and they were using angles to help them navigate. So that's why they were using a conformal projection, because they needed the angles to be correct. Okay, you can see that the latitude, longitude lines are not distorted by angle. Everything's at a 90-degree angle in this conformal projection. Here is an equal area projection, U.S. National Atlas equal area. You can see the angles are distorted, okay? So they don't look like normal right angles anymore, okay? But the areas are accurate. So the size of things, like say you were making a map showing different projected areas across North America, then you would be able to show the size of the protected areas accurately. So you want an equal area projection. So this is good for showing population either human population or wildlife populations, conservation areas, climate, for example, anything that needs to show area as its primary consideration, okay? These projections are called equal area or equivalent sometimes. All right, so this is an example of an equidistant projection. So equidistant projections reduces the distortion of distances. So this is a good map projection to choose if you want to show distances between things or routes or something, because it shows you how, accurately across the map how far things are. Okay, so equidistant, equal area, conformal. Okay, those aren't the only kinds, but that's three main kinds. You can also have directional types in your projection, which is the most common ones are cylindrical, conic, and azimuthal or polar. Okay, cylindrical is very common. And then sometimes you'll see the maps that don't look like they have a square shape to them. Those are the conical maps. Those are good for especially showing high latitudes, right? Because the place where the red line on these is touching is the place that it is the most accurate, okay? And then azimuthal are great for polar north or south pole maps, right? How do you choose a projection? Okay, so here are some things to think about. What area does your map cover? Is it North America? Is it Europe? Is it the whole globe? Is it just Wisconsin? Is it Dunn County? So if you have a map of Dunn County, the most accurate projection or projected coordinate system would be one that was made specifically for Dunn County. So one thing you can do is look for a search for a projected coordinate system that has the name of the place you're mapping in it. Okay. Okay, so what latitude does your map cover? So mid-latitude, often conic projection is a good way to go. The equator, if you're showing stuff by the equator, maybe a cylindrical projection. And if you're showing stuff by the poles, an azimuthal or polar projection might be good. What is the scale of your map? Okay, that's the same thing as what is your, similar to what area does your map cover, but use a local projection for a local map, use a global projection for a global map, okay? And then think about what's the purpose of your map. So three potential options are navigation, distribution of things, or travel. So if you are doing navigation, use a conformal, distribution, equal area, travel, equidistant. And then also think about what is familiar to your viewers or readers and what are other people using, what's familiar or common. You'll get to know what are common projections for the areas that you're mapping, okay? Remember, projection determines map units. So if you aren't sure what units your map is measuring things in, like in ArcGIS, it's calculating areas or lengths, but it's not clear what units they're in, go and look at the coordinate system that you're using, and that will give you a clue about what unit you're in. Okay, so I will stop here.